Okay, I have a 4-stack Donkey Kong board set that I'm going to be looking at. The other boards are over here. Here's the sound. Then you have the video and clock boards here. This is the CPU board. And what I don't have is I don't have a Sanyo monitor that accepts inverted video. So what I'm going to do so I can see this on my screen, looks broke. What I'm going to do is I'm going to invert the data that's in the PROM chips. And then there's this little jumper right here that you have to scratch because that's the background. If you don't scratch that, the background will be all white. And you scratch that off, it'll go to black. So to undo that, of course, you put the regular PROMs back in and then you just jump that. And then it'll be back to normal. So it's no big deal. But that's the 3 things that you have to do if you want to run it on a regular monitor, say a G07 or a modern LCD monitor or anything like that. It's gotta be the correct video signal. And Nintendo boards output an inverted video for the Sanyo monitors. It's just how they worked. Don't ask why. It's just how they worked. So yeah, I'm gonna do that first thing and get this data flipped, so that I'm doing it digitally. I'm not gonna add a bunch of junk up here because I don't want it to be permanent. Because whoever ends up with this board set might have a Nintendo Donkey Kong cabinet with a Sanyo monitor in it. So what I'm gonna do is I'm gonna do this repair. And then I'm going to put it back to normal. I'm going to jump that, and then I'm going to put the regular PROMs back in it so that it is ready for going in a Nintendo cabinet. So, yeah, that's what I'm going to have here. 4-stack Donkey Kong board set. All right, this is the CLK board of the Donkey Kong 4-board stack. And just looking over this board, it's got some pretty nasty chips. I mean, really crusty. So this thing was in a rough environment for quite some time, a moist, damp environment. I don't have any of these ECL chips at all. So I'm going to have to buy some, at least the 10124s, because I want to replace that. Any of these that are all rusted out, they look like they're going to fall apart. I want to replace those. Any of them that are nasty like this. And these 299s, I don't have any of those. I'm going to buy a few of those. Those are some kind of a shift register. I know I don't have any. And being that this has been in that kind of an environment where it's really crusted out, I don't have much confidence in these sockets. I'll pull the chips out and look at them. Yeah, but this is really bad. A lot of these chips are really terrible. And if you flip it over, some of them are even worse on the other side. Look, that one's got shit growing on it. Really bad. So as a maintenance issue, I'm going to be going through, and before I even start on this thing, I'm going to replace a bunch of this stuff. And those, I believe, are 283s. I think. There's a lot of 283s on this board, and they're all pretty crusty. That could be an expensive deal. Those are about $1.50 a piece. But I can't leave those on there like that. They're nasty. They need to be replaced. So a lot of these chips are going to be replaced right off the bat. Those are in pretty good shape. That's good. Most of the time those things are busted. Yeah, so most of this ECL junk looks okay, which is good. I hope they're good. I don't have any of that stuff, like I said. I will buy some of the 10124s on eBay because there's a couple I want to replace. Yep. The other boards look good. This is the video board. I don't see no problem on the video board as far as just the normal run-of-the-mill type crust. Nothing bad. As usual, there's a little bit of dirt, but it's not bad. This one's bad. You know, maybe this one was on the bottom or something. You know, got the worst of it. It's got some really crusted out stuff. So that'll be done before I even plug this thing in, as I'm going to replace a bunch of junk on this board. So, alrighty. Okay, I got the Donkey Kong board set hooked up. I've already checked power. I got good power everywhere. What I don't have is I don't have any clock signal. Nothing. Nowhere. No clock. So that'll be the first thing, is to look at this clock generating board and find out what's going on with the clock, why I have no clock. So I'll put like a foam piece right here and fold this over and start probing on the clock board. I got my scope probe on pin 6 of the Z80, which is the clock going into the Z80. And you can see I've got a really nice 3 megahertz clock going to the Z80. Now all my other lines are completely just non-existent. No, there's nothing going on. I got a lot of floating stuff. But the good news is that I do have a good clock going to the Z80. Full disclosure, last night, it was about 4 in the morning and I was a little delirious. I was convinced that something on this board was killing the power on the board. And I had this crazy idea to clip all of the power leads on every chip until my power came back. And it just turned out that I had my logic probe here hooked up wrong. And I don't understand. I checked voltage, and voltage seemed weird. I was checking the voltage at the wrong point. Because you know what really sucks is I don't know. There's no excuse. I'm going to have to go through and replace just about everything on this board, just to get it working. I've clipped all the power leads. I soldered them back together, but I don't know how reliable that is. So I know I got a good clock coming to my CPU, so this thing should be giving me something, and it's not. So, yep. I'm going to have to just bite the bullet and start replacing parts. Okay, I went ahead and hooked my TV back up just in black and white mode. And this is why it's better to have a TV than an LCD thing running a digital converter, a analog or RGB converter. Is I can see right there that I don't have sync. If I had sync, at least I would have stable garbage on the screen, which I don't. So what that tells me is I've got to check all my counts, all my horizontal counts and all my vertical counts, and that I believe comes off of this board. I'm going to have to look at the radar scope schematic for the 4-board set and just kind of go off of that along with the Donkey Kong schematic. See, it really sucks because for some reason you can't find schematics for this unless you own them. They're not online, which is really strange. It really kind of sucks. But I'll do the best that I can with looking at the old radar scope 4-board and then kind of going along with Donkey Kong and, you know, mix and match, find what makes sense, I guess. But I'm going to make sure that I have all of my horizontal counts and all of my vertical counts, because it looks like, by the looks of that screen, that tells me that I got bad counters. Now I'm not getting all of my horizontal and vertical counts. And that would explain a lot of my clock problems if I'm missing clocks. Because a lot of clocks are derived from those counts. You know, they're divided down and sent all over the board to run various things. So yeah, I'm gonna do that. I gotta go over the schematic and find out where these counters are at, the horizontal and vertical counters, and check those out. Okay, I'm probing around on this clock PCB. What I did here is I did replace the 5367s and the 245. I replaced those because I wanted to just make sure that all of the busing is okay. And then I moved on to this board looking at the counts, because I still have no sync. And to the touch, these, I haven't looked at the schematic, but I know that these are the horizontal counters, and they are piping hot. All three of them are hot. And I did double check my voltages on this whole board, and I actually probed all the voltages of these 3 chips, and they're all where they should be. I got 5 volts going into 5 volts and ground here, and then all of the signals are well within 0 to 5 volts, and they're just hot, and nothing else is really. These are hot, but they should be hot. They got heat sinks. But they're not as hot as those other chips, and everything else is. Ooh, that's hot. Yikes. Ooh, those are hot. Yeah, some of this stuff is really hot. And I've double checked and made sure my power was right. And it is. I got only 5 volts, neg 5, and ground coming into this. And I've triple checked it to make sure that it's wired right. I'm going to replace these 3 to start, because those they shouldn't be that hot. They really shouldn't. And they're hot. Ouch. So I'm going to do that. I'm going to yank those 3 out and replace them. Okay, I got all 163s out of the board, and they all tested bad. I desoldered these. I'm going to just make sure they're not shorted, make sure they're good, and then I'll put them back in the board. I've removed the caps, and some of these caps are really pretty suspect looking. Just kind of crusty. And why not replace them? I'm going to replace these counters. Those ones all test bad. And, well, that's a step, and then we'll go from there. Okay, I've got it hooked back up. You can see there's nothing. I got no clock coming to my three 163s I just replaced. There's no clock. They're not being clocked. Now they just... See, this clock signal's awfully flaky. So that's the next thing I'm going to have to check. It just went high. It's just not doing it. I got it set at 10 milliseconds as well. I'm going to set it a lot faster. Let's go to 50 microseconds. And yeah, you can see now it's just high all the time. There's no clock. These aren't being clocked. So there's no count. And the good news is they are not hot at all. Cool to the touch. Those other three, you know, counters are some of the hardest working parts on a board. So they fail a lot. They really do non-stop counting. You know, it's just... I've experienced a lot of bad counters. They fail. So it's a good chip to keep a ton of them in stock. Yeah, there's no clock to this. I got it plugged in. You know what I did do? I removed these. And if you don't have deoxit and you work on boards, you need to buy some deoxit. Deoxit is a miracle worker with pots. It just renews them instantly. Okay, yeah, that's nice and cool, good. So that's one thing. I had 3 blown out counters. And now they got no clock. See, it's flaking. It just tried to start getting a clock. 1, 2, 3, 4, 5, 6. Now that's my CPU clock. There's no clock to the CPU. And this is the clock signal going to my horizontal counters. Sometimes it's really flaky. Sometimes it wants to work and sometimes it won't. So, and you know what really sucks is, why couldn't Nintendo just be like every other company and use 7404s? Their clock generation uses these stupid ELC chips. ECL stands for emitter coupled logic. And all I know is they work on basically ground to -5 volts, whereas TTL is 5 volts to ground or ground to 5 volts. ECL is the opposite way. They work on 0 as a reference and then to -5. Yeah, and I don't have any. And these things are hotter than hell. A lot of them are. So, and I know that these ones right here, these 2 ECL chips and probably these 2 are all part of the clock generation circuitry. And this one's hotter than that one's really hot. So I'm afraid that I'm going to have to buy some of these stupid ECL chips. Yeah, this one's really hot. But I got no clock. I got nothing going, there's no clock. And these counters are like the first thing that the clock hits. Is the clock is generated, and then it goes right to the counters to set. See, now it's trying to do something. Now it's trying, see, now it goes away. I guarantee I got bad ECL chips on this thing in the clock circuit. I got to look at the schematic and see exactly how the clock is generated, and then I'll start probing that, and I'll be able to prove that these are bad. But right now it's just a guess until I can prove it, and I got to find a schematic. So, and that's the tough thing, is I don't have a schematic. Donkey Kong schematics, like current 2-board stack schematics, will probably translate to this section. So that's what I'll look at and try to find out what's going on with this junk. Okay. Okay, I'm starting at the beginning of this with the crystal, and I captured this coming off of the crystal. So it is oscillating. Let me hit run on that. Now, according to the schematic, there's the crystal right in the center of the screen. It comes off of the crystal and it goes through, basically it ends up going through 2 transistors to amplify it. They're just amplifying transistors. And then it goes through this little T1, it's like a transformer basically. And then it comes up, the signal comes up and it goes into 10116, which is one of those ECL chips, in pins 12 and 13. Okay? And we know the crystal is oscillating. So, let me take my probe. We know the crystal's oscillating. This is the little transistor, or not transistor, but transformer thing. And I just looked at it, and it's not broke, so no wires are broke. The wires are good on it. And this is 10116. It comes into pin 12 and 13. So 9, 10, 11, 12, which is nothing. And pin 13, which is also nothing. That's 13, that's 12. They're both just kind of a little below 0, but there's no signal on it. And we know this is the crystal oscillating. So the crystal is oscillating, but by the time it comes out to here, there's nothing. So I'm going to have to remove this big stupid thing. And I'm going to check in there. There's a couple transistors in there, and I'm going to check that out and see what is going on underneath this metal thing. So that's the next thing I'll do. Well, I've been doing some maintenance work. I decided to just go through and remove all the rusted out chips, and this is the pile of trash. I mean, these things got legs breaking off, and I mean, they're awful. Rusted, gross. Look at this one. And what chips did come out with all the legs on them, I put in my chip tester, and only a couple of them were good. So this board really needed a lot of work. But those were all the chips that just had really bad crusty legs. Now look at the dirt that was underneath these, and that's like sandy dirt. It's weird. This one really needs to be replaced. Yeah. I pulled a couple of the ECL chips. Look at this one. Look at the dirt. Yeah. All right, yeah. Next thing I'm going to do, I think I'm just going to clean this board. I'm going to wash it. Get some of that dirt off of it before I repopulate it. I'm going to clean it. Yeah. Okay, I just cleaned this board with the usual treatment. It really came nice and clean. I always say a clean board is a happy board. I do not like messing with nasty boards. I removed another chip since my last entry. This is another one of those ECL chips that will just get flaming hot to the touch, so I know it's no good. And the funny thing is, these used to get really hot too. I removed that, and now these don't get that hot. I don't think these are going to be any good. I hope that they are. I don't want to have to buy two of these. I did buy 125s and 124s. I bought five a piece. So I won't be able to really continue on this board until I get them, which will be sometime next week, a few days, probably four days from now, probably. Something like that, 4 or 5 days. Yeah, nice and clean. Guess I'll go ahead and repopulate these while I'm waiting on other parts. All the other chips look good. They look okay. And none of them are very hot to the touch. Actually, some of these, I think like this one might be, I'm not really sure. I don't know what happened to take all these chips out. This board is terrible as far as bad chips. Yep, I'm going to go ahead and get to, I guess I'll pop these chips in and solder them in, the ones that I can. Okay, I got new chips installed. The ones that I had anyway. I don't have any of this ECL stuff yet. But yep, it's looking good. There's still some chips I might just change for the fun of it at this point. You know, like I don't know, maybe that one. I don't know. That one, maybe. I don't know. I'll probably just leave it alone and see what happens now at this point. Yeah. I did remove that one. I don't know if I had said that before. I think I did. It was about burn your finger when you touched it. So yeah, I did say that. Yeah. Wait on these ECL stuff. I just ordered 10 125s and 10 124s. So I'll have to wait on those. It's looking good with the new chips. Good thing about it, I mean, this board has a little bit of corrosion stuff going on, but it's not so bad that the board is trashed. It's still usable. It'll still work. All the traces were fine. So, yeah. Yep. Really quick, this clock circuitry here, which I still don't have any kind of clock floating, and I'm missing, I just want to see the clock get to this point right here. I know I'm missing chips that are involved in the clock circuit, so I just want to see it get to here. And if you look at the schematic, you have the two transistors, and the clock signal is going into the base of Q1. And then it's driven into the base of Q2. And then it's taken off of the emitter and goes into T1 there. So what I'm seeing here is there's the clock signal off the crystal, and then it goes into the base, which is emitter collector base. It's right there. The base is tied, or collector is tied high, and then off of the emitter it comes out, and then it makes its way over to the base of Q2, which is right here, and the collector is tied high again, and then it goes through, and right there it's just tied low, stuck low at the emitter of Q2. So Q2 emitter, it's tied low. Okay. You got a capacitor and resistor at R6 and C142. Unless C142 is short. I suppose C142 could be shorted, shorten it to ground. I mean, that's the only thing to check, really. Other than that, Q2 is bad. So I will, at some point, I'll pull out C142 and just check it and make sure it's not shorted. Yep. I guess that's what I'll... C142 is probably this guy right here. Where is C142? Do I got that right? C142? It doesn't seem right. I don't know. I can't read that schematic hardly. I guess I'll trace it out if I can't. Is it C4? C9. Can't find it. Let me look for C142 and see if that is causing that to be grounded. Alright, I'll check that out and get back. Well, it just hit me that I was looking at schematics for the 2-board set. That's why I need schematics for this 4-stack set. You know, not everything lines up, and I can't even read the value. Is it, I think, 10 picofarad on that schematic? I don't know. I can't read it. So I'm going to actually have to trace out this circuit to find out which cap to look at. Okay, I'm back at the Donkey Kong board set here. I replaced the 2 oscillating transistors, and I'm now probing the collector. I don't remember if it's the collector or emitter that has the signal. I think it's the emitter. The emitter has the signal coming off of it. And remember, this one right here had nothing coming off of it before. And now you can see I have a nice 61 megahertz sine wave. Exactly what it should be. So that is good. I got the clock successfully to here. And then it goes through this thing and comes out to this chip. I'm not exactly sure which leg it connects to here. I'm gonna have to check that out. Let me look at the schematic and find out where that signal goes to so that I can follow it to here. Okay, this is pin 6 of a 10116 ECL chip. And you can see right here, I have my 61 megahertz clock signal. And over here on the schematic towards the left, you see pin 6. So far so good. I'm going to continue on. Okay, I'm back to work on the Donkey Kong clock PCB. This bottom line was really crusty, so I have decided to bite the bullet, and I'm replacing this whole bottom line. I'm going a step further. I'm replacing all of the ECL. I'm just kind of renewing this board. It was so bad. So I got all of the ECL removed. Yep. That's what I just decided to do that. I've purchased from Mike's Arcade. I purchased all new ECL chips. These ones, they're expensive. I'm going to tell you right now, one of them was $25. I don't know which one it was. I think it was this one right here. 10136, I believe, was $25 for one chip. The RAMs were $9 a piece. So it's going to be an expensive board, but it'll be a reliable board, and that's important. So I mean, half of it's brand new. So more than half of it. I'd say more than half of this board has been replaced due to crust. That is amazing. But yeah, it'll be super nice. Alrighty, I'm gonna pop some sockets in here and then I'll be ready for the ECL. Okay, here I am back at the Donkey Kong again. I got sockets in, and this is actually 24 pin, not 22. So I had to cut another pin, another section of a 22 pin socket here so that I could fit this in. But I got some of the ECL in. This is all the clock circuit right here. All this. And the good news is, this is where the clock goes in. We got a clock. And it's being divided down. these two are nothing. This is the most significant bit of the horizontal count. So I now have the main clock out of the way. I have to put the remaining ECL chips in here. That's all 125s and 124s. I've got those. But these are the ones that I got from Mike's Arcade. This one right here, the 136, is the $25 one, I think. And the two RAMs, I got those from Mike's. I'll probably take the old heat sinks off and glue them on. But yeah, awesome. Okay, we got the Donkey Kong put together. Here's my nice newly redone clock PCB. This is running. The program is running in the background. There's no sync. But I can tell the program's running. I don't have sync. I'll show you on my scope. This is the red signal. It's very active. This is the blue signal. And this is green. Green looks really active. Ground. Nothing. And this is my sync line, which is basically nothing. I have no sync. So I got to go through the schematic and track down the sync, horizontal and vertical sync generation, which shouldn't be no problem at all. Really, should be easy. It's probably on the video PCB, this one here. So I'll take a look at it and I'll figure it out. It's probably dead counters. No big deal. Alright, cool. This one's almost done. I just wanted to really quick kind of show how the horizontal and vertical signals are created. It's kind of cool like this. This is the first stage of the horizontal count. Up on top there, that's 6 megahertz. 6 megahertz goes in, and that's what gets divided out. So, and then it goes to the next one. So I'll just move it over to the next and hit sample it. That's the next one. See how nice that looks. That's this clock PCB being rebuilt with new chips and stuff. Look how nice that is. Then it goes to the next stage. Sample that, and that's only the top 2 lines right there. And then that goes over and clocks the vertical counters right here. There's only 7 vertical lines. Here's the first 4. See how nice and clean those are. And then the top 3 are the actual of this one. And the bottom one is a different signal. It goes off to do other things, but the top 3 are the last 3 of the vertical. When you see 128V, that purple one is 128V. You know, 128V, 64V, 32V. That's those signals. So I don't have sync on the monitor. It's not because of these counters. The signals are getting lost somewhere. It might be these interconnects. I don't know. I'll figure that out. But yeah, I just wanted to show that on the scope, those counts. and I'm really happy with how they look. Look, that's beautiful. Perfect. This is a really nice board now. A bunch of new parts, new chips everywhere on this thing. It's nice. Okay, that wasn't really part of the repair. I just kind of thought that was interesting and someone might like to see that. I'll see you when I get back to actually repairing it. I'll be back. Check this out. This is of course this is inverted video, but it still looks like some of the colors are not going to be right. I'm gonna have to flip the color proms. I'm gonna have to flip the data in the color proms, and then these two guys right here, I'm gonna have to flip all the data in that and then scratch that, and that'll give me proper colors. But yeah, those bars in the background, I don't know. I mean, I really don't know what to expect until I get the colors inverted. But it's pretty cool. It's working. I mean, it's running. It's all kind of trivial now with just color and maybe RAM or something. I don't know, you know. But I'm going to get to inverting all the video so that it at least pictures right. So I'll do that and we'll see what it looks like. I just wanted to show how I inverted those proms, the color proms. Because right now I'm just kind of verifying through to make sure I did it right. I got the line highlighted that I'm checking. This is, right here is the original Donkey Kong 2K. This is the original. This is the inverted 2K that I inverted. And what I'm doing here to verify it is I'm reading off in my head, and I'm kind of saying it out loud what the inverse is, and then I go over here and I verify it. So if I do that, the inverse of this line right here is 050F. And I come over here and just make sure it's 050F. And then back here, 050F again, 050F. And then 050F again, and it's 050F. And then 005F. 005F. I've just gone through this whole ROM and verifying that I didn't mess anything up. And then once it's verified, I'll go ahead and burn this file into the PROM. This is the inverted version of the original Donkey Kong file, and that will flip the colors. Okay, I got the video inverted for this monitor. This is a G07. You can see I got my two proms I burnt, and I scratched that off. That's the background. It'll either be, if it's shorted, the background will be white on this monitor but black on a Nintendo monitor. So I have to scratch it off for a regular monitor. It's cool that Nintendo included that stuff. But yeah, not everybody can do that, you know. But yeah, so it's got issues. Looks like it's got RAM. There's probably a RAM problem. Amongst other things, the video PCB probably needs work. I would imagine that the video PCB does need some work, so I'm gonna look at the main source code and see if the CPU accesses video memory. You know, as I really don't know much about Donkey Kong's hardware, I'm going to study up on the hardware a little bit, see how it works. It'd be great if I can just put my Fluke on it and I could easily find out what RAM is bad. Would be nice. So yeah, that's the first thing. Is my first thought is RAM, so I'm going to look into that. With the Donkey Kong PCB, I want to use my Fluke right there. I want to use that guy, but the Fluke does not like these Nintendo sockets. It won't, I can't get a good connection with it. So what I'm going to do is I'm going to replace this socket and put a regular type socket in there so that the Fluke will have a good connection and I can actually use it. Because right now I can't get a connection in this socket. So I'm going to go ahead and replace that socket there. And then I'm going to hook the Fluke up to it and run some RAM and verify ROM and all that good stuff that you can do with the Fluke. I'm running a long RAM test right now. You see it's doing some funny stuff on the screen. I got to hook back up to the black and white. I'm doing a long RAM test on this video board. There's 2 RAMs here, 2 RAMs here, and I'm doing a long test on that range because there's funkiness on this board. And I went through and I made RAM regions. I had to basically use my logic probe here and probe out and run a loop on the Fluke and find out what RAM is what ranges. I've been doing that. I was using the main source code over there on the TV, but it's not exactly correct. Like it says that there's RAM in spots that there's not RAM. And anyway, this is the video RAM is these chips, these ranges, all this. I got this all kind of documented here. And this is the 3rd time I've run this long RAM test. And so far I've had 2 errors. And they fall within this range, which is 5M and 5L, which is these 2 guys right here. Now the RAM themselves I don't think are bad. I think it's the circuitry around the RAM. And I also want to check the ROMs. This might have a bad ROM, causing those bars across the bars in the background. That might just be a bad ROM, but there is funkiness in this RAM circuitry. So I'm going to verify these 3 ROMs, and I'm going to have to find a problem in this area. I'm sure of it. I'm doing this long test, just hanging out, letting it run. Like I said, I've had it caught 2 errors, and it's always in this range. So it's got to be the circuitry driving these 2 RAMs. Something's funky. So I'll let this run through, and I'll be back if I find something. Okay. The game kind of froze up. You can see where Mario fell through basically a crack in the bottom girder. There are character issues. I think there's sprite issues too with Donkey Kong. Donkey Kong's kind of funky, but there's big time character problems in this game. And this is the character section. And I just got this error. I did just a RAM short in this area, and it spit this back. And I'm going to start looking at this 245. It's the data path between the CPU and those RAM right there. So I'm going to probe that guy right there and see what he's doing. See if he's working or if he's working good, then I can eliminate that as a problem. But since I had a data error here, and it's a lot of bits, D3 is a lot of bits. So I'm going to look at that guy. I'm going to hook up. Be right back. Okay, I went through and replaced those 3 parts. I was just hoping maybe that'll have something to do with it. I'll tell you what, I'm kind of glad I did anyway. They were, if you remember on this board, how some of these chips had like what looked like sand underneath them. It must just be dried up dirt. These 3 chips had a lot of that underneath them, so they didn't look good, so I replaced them. But it didn't make any difference. I still got the lines in the background and the graphical issues. So I'll have to work around that. But yeah, those 3 parts right there were not the problem. So yeah, so oh well. I'm going to work the video board first. This board, I want to make sure this board's working first, and then I'll move on to this one. I think this one has issues too, to be honest. This is basically all the sprite data in there. And you can see Donkey Kong right here. He's got funkiness on his face. That's a sprite problem. And he's fine right here. I really believe these lines come from the character area, the character part of the board. But you never know. I mean, it's whatever it is. And then this funkiness right there. That looks like moving parts. That looks like a sprite issue right there. This funkiness right here. I don't know. We'll get it though. So I think there's issues here still. Even though I replaced a lot of this, I think there's still issues. Maybe with the serializers going out. Who knows? We'll figure it out though. And this board's, I believe, has some issues on it as well. I did pull the ROMs and I verified them. And they were kind of flaky, to be honest. They verified, but they didn't want to verify all the time. So I don't know. I might replace those. All right, but I'll continue on with the video board. I'm gonna work the video board because I know I have issues getting to the RAM with the Fluke. So. And now I know the RAM are good. It wasn't the RAM and it wasn't the 245. It's the surrounding circuitry that is also involved in that circuitry is what's bad. So I'll find that. So I'll be back on this. Well, it's been a while since I've visited Donkey Kong. And if you remember, well, it's just a cut in the video for you, but for me it's been about 2 months since I've looked at this. That's what I got on the screen, the bars in the background and goofed up sprites. I found something, and since I don't really have a good schematic to go on, I'm just kind of poking around with my scope and looking for goofy stuff, and just no real scientific method to it, to be honest. I'm just poking around. That's about it. Anyway, and don't get me wrong, I can use this schematic a little bit and just kind of try to translate it to work to this board, but I'm not to that point yet. This is just kind of I'm not in a hurry on this, so I'm just kind of poking around on it, like I said. Anyway, I found something that is goofy. Coming into this 367 driver here, this is an input. And its output looks like this. It's buffering it, and it looks like that, the output does. But this input is no good. So I'm gonna trace that back to whatever that came from. And I can probably use the schematic and look up this 367, but the locations won't be right. That's the problem. So I'm just going to manually beep that back to wherever it goes. I have no idea where it goes, but I'm going to find it, find out what it is, and go from there. See what's generating that garbage. Alrighty. See you later. Okay, really quick. I found where that funky dead signal, that's the yellow one up there, I found out where it's coming from. It's address 15 off of the CPU, and I did already swap a different CPU to see if it was just that address bit was blown out in the CPU, and it's not. This is the same thing, address bit 15. The highest, the most significant address bit is dead. That is interesting. So I am going to have to pull out the 2-board stack schematic and just see what the highest, where that goes. It's got to be used in decoding. Remember, I couldn't get to these, I couldn't really get to these RAM good, because if you see, this is the input to the outgoing buffer, and this is, every now and again you see it spike, so it's trying to do something. That's the buffered output right there. So I need to find out what address bit 15 is doing, and go from there. It's something with that. So I want to find out why address bit 15 is goofed up. So that'll be the course of action here. The first thing, I found something that's weird, so I'll investigate that. Okay, I decided to sit back down with the Donkey Kong PCB, and I got my Z80 pod on there again. Like I said, if you remember, of course this is going to be just a couple of minutes ago to you, but to me it's been a couple of months since I've worked on this. So I'm getting a read-write error, which is a data error. And it's always a data error. It's never a decode error. So that tells me that that is something with the RAM. And I did replace this. These are the associated circuit. This RAM range is these guys right here, and I've already replaced those, and that wasn't the problem. The problem is I'm looking at the schematic. And this is what I got on the screen. I'm looking at the schematic, and what I'm going to look at here. These are the two RAMs right here, the two 2114s. Okay. Now up here on pin 8, I have a chip select line for those, and then I have on pin 10. I have coming over here a video RAM write, and then I got video RAM read. Those two signals right there. Video RAM read goes through this LS08. I think that's a 08. This is the stuff I want to look at. I want to look at these signals. video RAM read write, video RAM read, where those come from. I need to start. I'm going to start right here, and I'm going to look at this 08. I got muxes up here that give me the chip select line, and then I have the enables here, the write enable and read enable. Well, actually, the video RAM read fires up this 245 right here, and the write signal is the direction. It gives the direction on the 245, and it fires up the two 2114s. So, yeah. This is the kind of stuff I'm going to look at first. I'm going to start with this 08. I'll probably go through all of the muxes. This is 1, 2, 3. I think there's 4 muxes in this block. Maybe. Donkey Kong schematics are hard for me to read. It's all, I just don't like how they do this stuff, but it's like deciphering something. But I can read and write to every other RAM on this board set that I'm supposed to be able to. Okay? Except for these two guys right here. I cannot get to those. So therein lies the problem. Right here. The muxes, the signals coming from way over here. I want to find what is generating these two signals. I got to check this 08, make sure it's operating good. So that's what I'm going to do. I'm going to start just by probing these signals when I do a read write or whatever. See, make sure they're doing what they're supposed to be doing, going low when they're supposed to, and that stuff. So I'm gonna put my, I'm gonna get my scope out and I'm gonna set it right here. And as I hit RAM short, I'm gonna sit there with my probe and kind of look at signals. And then I'd like to, these muxes right here are the ones that are in that schematic. It's this block, I believe. I think. Now, remember, that's a 2-board set schematic. So I got to make sure that, and I do believe that these are the muxes that work with this stuff. You know, as I got another 245 up here that work with these two RAM. And I got some 157s here. Probably half of them are for this and half of them are for that. It's probably these 3 are here, these 3 are up here. Probably. I would imagine it's something like that. So, yeah, I'm going to just kind of probe some enabling signals. I'm going to find a 08, and I'm going to have to just manually trace it back. You know, I'll continuity. I'll put my continuity between whatever the schematic said that 08 enables. I don't remember. I'll look at it, but I'll beep that out and make sure, okay, that's the 08 that I need to look at, type of thing. So, alrighty, let me set the scope up and we'll take a look at some signals. I'm just kind of probing around. I got my analyzer here on LS86 right here. And I'm probing pins 1, 2, and 3. Which 1, 2, and 3. And I'm just kind of curious as to what the point of this is. I mean, it could very well be that this is the way it's designed. I don't know. But this is curious to me. Why have two high lines going to an LS86 just to create a low? Why not just tie it to ground? I'm curious as to, is there a signal missing here? It could very well just be supposed to be this way, but I want to trace these lines back and find out what they're coming from, how they might just be tied high. Who knows? But I want to find out. So that's one thing I'm putting in the back of my head, to look at where these two inputs are coming from. All right, keep digging. Okay, I traced that 86. That 86's input that I wanted to look at, that was always high or low or whatever it was. It came from this, one of the pins. I know it came over to this, so I just decided to hook up to this and look at it. And this is the very first part of this mux. This is a 157 mux. And this is what's going on. You got up here is enable. You got enable, select, 0-bit, 1-bit output. So it is selecting 0 all the time, and it's sending 1 out at all times. I'll run it repetitive. It's always sending 1 out, the 1 line. It's never, and I've got it triggered on, I'm triggering on the 0 line, activity on the 0 line. It is always sending the 1 line out. Well, something's funny here. So I am going to continue. I'm going to continue to look at the other parts of this mux, the other, you know, there's 4 switches in this mux. I'm going to look at them all and see if I'm getting similar nonsense. So that's definitely not right, because I went through all of these muxes, all 3 of these, and they were all perfect. So this one is not. That is incorrect. It's always selecting the 1 line. Always. I shouldn't say it's always selecting the 1 line. It's always outputting the 1 line, even when it's being told to output the 0 line. It's always supposed to be outputting 0. So this should be down here. Instead, this is. So I'm going to go ahead and continue. I'm just going to continue, look at the other switches in that mux. I'll be back. Okay, I just got to the 4th and final switch in this mux, and the 4th one is the only one that looks like it's working right. It's always enabled, and it says select 1, and it's always outputting 1. So this one actually looks right. The other 3 are all wrong. So that is a huge issue. I'm going to have to replace that 157 because it's no good. Alrighty. And just for fun, remember I had this on my analyzer. I hooked it up to my oscilloscope just to look. And this is the one, it was always sending the 1 select, or the 1 input to the output, no matter what the select was telling it. And you can see it here as well on my scope. You actually see the exact same thing that you saw on my analyzer. It's always selecting 0. This is the 0 line. That should be on the output. This is the 1 line. and it's always sending the one line down to the output. So that just verifies with my oscilloscope here what my analyzer was saying. Is it's just basically shorted the one output, the one input to the output is basically what's going on. It doesn't matter what is going on up here. It's saying, I don't care what you're telling me, I'm sending this guy out. So yeah, I got to replace that. That is, I just wanted to hook the scope up to it and see if it would tell me the same thing, and it does. So the 157's got to go. So that's the next step, is I'm going to replace that. Alrighty, I'm back visiting Donkey Kong, the Donkey Kong board set. I found something that is a little suspicious. I got my oscilloscope out and I'm probing right here on pin 13 of this guy. It is an LS299. It's an 8-bit shift register. And it takes data inputs from the ROMs, directly input these two guys, and then they just shift the data out to muxes, I think, and then it basically creates I'm not exactly sure. I have to look at the schematic a little bit more, but I know it's in the video section. But I'm finding something that's a little funny here. We got 11, 12, 13 on this guy. 13. And this is what it looks like. That is not a good signal. And the other inputs all get inputs like this right from the ROM. But I have probed all of the data lines coming from these two ROMs, and I haven't found anything that looks like that. They all look good. These are all the data lines coming right off the ROM. Yeah, and then the input to this guy is just garbage. So either this guy is pulling that line low, or there might even be a broken trace. There might be a bad trace in here, because this work was done prior. That I did not do this work. So I need to find out where this is coming from. Is according to the schematic, these are these two shifters right here, the two LS299s, and they take data straight from these 2716s and input them. There's 8 bits that get inputted, and then it shifts out and goes over to this mux here, and it creates 2 bits basically. So I should be able to probe these ROMs and find that bad signal, because it's a short right from the data line, the data output from the ROM to the data input of the shifter. But I'm not finding that. So in this schematic, of course, is for the 2-board set. So I think what I'm going to have to do is actually unhook the board and take it and follow the trace to see where it goes, because this gives me the general idea of what's going on, but these locations aren't correct. So I see that pin 13, which is the B input, is connected to pin 16. I think that I can't read that. Or no, I think that says D6, 16, yeah, I think that's pin 16. Which doesn't make any sense, because 13, 14, 15, 16, 17, yeah, okay, yeah, 16. So it should just be 16 of the ROM connected to 13 of the shifter. So that's what I'm going to look for. I'm going to look for data 6 going to B on one of these. You just try to trace it down and see where that's coming from. That's not a good signal. So I need to know, is this pulling it low, or is it a bad trace, or what is going on here? So I'm going to look into that, and I'll report back when I figure out what's going on. Okay, I'm going to show you right here that pin 13 of this guy that I was probing that looks dead comes from pin 16 of here, and you can see right there that trace is broken. It comes right down to here, and then it goes over to 13. So I am going to have to pull this socket because I want to fix it right. This one I've already beeped out. That is not broken. This one is broken. So I'm going to go ahead and I got to pull this out. I got to pull this socket out and fix that. Yeah, that was a tough one for me to see. I didn't notice it when I was first cleaning this board up. But yeah, there it is, broken trace. So I'll go ahead and fix that, and I'll be back. Okay, and that is how I fixed that. You can see right there, I have a wire soldered through the through hole, and then it's soldered down to the trace, bridging it, and then it goes down through the through hole here. So I'll put the socket over that and solder it back in. Okay, I did solder the socket back in, and I fired it up, and it did fix the graphics issue with the bars in the background. That's all cleared up now. But it didn't fix the data accessing problem, which I knew it wouldn't. It was kind of unrelated, but it did fix the bars. So what I'm doing now is, because what I'm trying to do with the Fluke, I can read and write to all the RAM on the board. These guys, these two guys here, I can read the ROM perfect, but what I can't do is read these two guys. And sometimes it works, sometimes it doesn't. It's really flaky. So what I'm doing is I'm going to look at these two signals right here. Video RAM write and video RAM read. This circuitry that turns these guys on, I'm looking at that circuitry right there. So, you know, they're VRAM busy. I'll probably look at this stuff too. There's a VRAM busy signal. I'll look at that, make sure that's good. All these video RAM control lines need to be gone through. But since that's the 4-board stack schematic, or that's the 2-board stack schematic, I'm manually tracing out all of those control lines. And so far what I've got is the 08 up here is an and it's this guy over here. In the schematic right there, it's got pins 10 and 9 out to 8. And that AND gate there comes up, and it's the enable for the 245. And it goes up to a mux. But I'm not worried about the muxes. I've already checked those. They work. So this guy right here is an 08. And it's this guy right here, and that output comes off of pin 6. The inputs are video RAM read and video RAM write. And I traced those through this connector, and that's where I've gotten so far. That's something, those control lines are made on the CPU board. So it's looking like a CPU board problem. Well, it's a video RAM section problem, but it's on the CPU board. So I was kind of making myself notes here while I was tracing this. And I'll find what is generating the control lines for that bit of RAM. These guys right here. Something isn't right making those control lines, because it shouldn't be no big deal. I got the Fluke in. It's a 245. It's the RAM, and it's an LS08 on this board. That's it. That, you know, and the 245 has to be enabled at the right, all that kind of stuff. But all I'm doing, and these are new, and this is new. All I'm doing is I'm writing to them and I'm reading back. So it's the write and the read signal, I'm convinced, are not right. So that's what I'm tracing back. I'm going to find, I can go by that schematic and find out what type of chip is involved in it. But I actually have to manually trace it from pin to pin on this board set because I don't have a schematic. So that's where I'm going with it. I'll find it. I'll find the bad part. It's just, this is kind of irritating to have to not have schematics and have to do this. But we do what we got to do. Alrighty. I'll get to that and let you know when I find something. Well, I'm back to looking at Donkey Kong, and I'm looking at the colors. See how Mario's wrong and Donkey Kong's wrong. This is the color prom. It's right here. It has addresses on 1, 2, 3, 4, 5, 6, 7, and 15. Outputs 9, 10, 11, and 12. And I'll just go down the line. Here's all the addresses. They're all moving. 2, 3, 4, 5, 6, 7, and 15. All the addresses are moving fine. And here's pin 9. There is no output on 9. Here's 10, 11, and 12. We're missing a color bit on pin 9 of this guy. It's a prom chip. So I'm going to have to burn a new one of those. Okay, I got that prom and I read it, and it comes up on ROM ident, so it's not the prom. I'm going to suspect that this 174 is pulling this low. So I'm going to replace this 174 right here, because that should never just be held low, and I believe this guy's pulling it low. So let's replace this 174. Okay, I ended up having to replace the prom anyway because one of the legs fell off of it. So I went ahead and burned a new one. I replaced this 174 here, and I followed it to the next step and I replaced this 157 up here. Neither of those were the problem. So I'm following the color bits. They come out of the prom, They get latched here, then they get muxed with these two guys, and then it comes all the way over and gets into these latches, and then they drive these two proms here. So since these two latches here have the legs where I had snipped the legs, power leads, I'm just going to replace both of those, and we'll see what happens. Okay, I got the colors fixed. The color problem is resolved. The Donkey Kong and Mario. You can see now Mario is looking good, as is Donkey Kong. Got a little artifact action going on right there. I tracked the problem down to this ECL chip, which I had bought new. I went through, and the ECL chips that I pulled where the legs were pretty clean, I kept them, and I just went ahead and checked them all. And this one was bad, this one was bad, and this one was bad. So there were three, well, there were only two bad ECL chips in the board. The one of them that I bought was bad. That's ridiculous. It's irritating. But these are the two bad ECL chips right here. The ECL RAMs that I took out of the board are good, which is awesome. So I'm putting those in the board, keeping the ones that I bought. I basically, anything that was good that I pulled, like these were original, and they're ceramic. I like that they're ceramic. The ceramic chips are pretty cool. But yeah, it's closer now. I mean, it's this little artifact action going on. So I'm going to continue. I think the problem is going to remain on this board. Some of the stuff that I didn't replace, like these two muxes, are kind of suspect. I really need to look at, I'm going to continue to look at this board. So, alrighty. Alright, as you can see, I hooked the analyzer up, and I'm checking the bus drivers, bringing, I believe it's horizontal or vertical address lines over through these connectors onto this board. Through these 367s, there's two of them. And right now I'm on this one, and you can see this is what they're supposed to look like. In and out. Same thing out as in. Now, if I switch it over to this driver, and kind of, you can see this one is no good. And this is the only, there's only one gate that's bad. I checked all of them in those 367s, and this is the only one that's bad. So that needs to be replaced. I'm going to replace this 367 here, and hopefully that will fix every problem on this board, because that would absolutely answer the problems of my addressing in these muxes. I went through, I don't have a schematic for this board set, so I went through and traced out all of the beginnings of the address lines, not the address lines, but the selectors for these muxes. Just every step that they took on that board before they came over here. And then I just looked up here and I seen these 367s, and I was like, I better check those, because that's the That's the horizontal and vertical addressing coming over. And yeah, that one's no good. It's just one signal messing up the works. So I'm gonna replace that 367. About this 367 up here, the reason it looked weird when I was probing it with the analyzer here is because there was nothing connected to those two pins. It was an unused gate, and for some reason this analyzer, and this is a problem with not having a schematic, is I just went down figuring, okay, there's every one of these gates is probably being used. Well, it wasn't. And with this analyzer here, floating lines act funny. It's like they pick up what's going on around them, and so I didn't realize that. That's why it looked weird. But it doesn't matter. I replaced it anyway. So, but yeah, I just wanted to explain why that looked bad, but it wasn't. Okay, I replaced the 367 and I got the exact same thing. And the old 367 tested good in my tester. So what I have to do is, number one, I have to look in the schematic, in the two board schematic, and find the 367s and find out what these signals are, where they're attached, what's attached to them, because something is freaking these things out. So I gotta find out what these are attached to. I might have to just trace them out, but I'll do that. I'll find out what's connected to them and start looking outwards from those pins. So that'll be next. Alright guys, well, I'm just going through and checking the data latches here on this video board, and I checked this one and it was fine, and I moved on to this one right before it latches the data that goes into this RAM. And you can see here, this is the input. You can see I have an input, and here's the output. The output is always low. So just to verify, let's see if it's a timing thing. This is the clear up top. I'm going to disable that. There's the clear up top. That's the clock. And line 2 is the input, and line 3 is the output. So the data is active basically when this screen is up, when the game screen is up. So we got activity here. Let's just stop it. Let me touch screen. Come on. Alright, let's hold on a second. I don't want to use the trigger or nothing. I'm just going to wait for it to... You can see there's no activity on line 3 on the output. But just to make sure that it should be... Okay, let's just go ahead and use the delay. Okay, here we go. We have some waveforms here. There's a rising edge of the clock and it's high. So this should definitely have toggled right here. It's just absolutely missing a data signal. So I need to replace this 273. And hopefully that'll get rid of the weirdness that's going on there. This board's really close. So let's go ahead and swap this 273 and see what happens. Okay, I did replace that, and I socketed it because I put it in my tester and it tested good. So I wanted to put that in a socket. So if I had to lift the leg out to try to isolate what was actually bad, that pin 9, was connected to this 283, which I replaced, and it was also connected to this as an input or an output, I believe. I'm not really I don't know. I think it was an output and then input into this, and it went, and it was an output. I don't know. Anyway, it was connected to this, and I replaced these two as well. And I do now, it is now moving. That's pin 9 now. It was stuck low, so yeah, being that it tested good in my tester, I just tested everything that was connected, or I removed everything that was connected to it and replaced it. But I still have the goofiness, which if you wait a minute for the next screen, you can see it's still up there, that goofiness is. So I've continued probing around, and I was looking at these muxes. I believe these are, I believe they're address muxes for the RAM. I'd have to look at the schematic though, I don't know for sure. But anyway, I came to this guy right here, and you have an input. This is an input to the mux, and the other line is tied low. So it's basically the select line here is selecting between low and high really fast, basically. Now the output is always low, which is really suspect, being that I have this input. I mean, that's a toggling input. I should have something toggling on the output, I would think, but I don't know for sure until I hook up to that and actually look inside the chip. So I think that's what I'm going to do, is I'm going to look at this guy, and I'd like to know what it actually does, but I don't have schematic for this board set, so I'm not exactly sure. I think it's just an address. These 3 muxes right here, I believe, address these 2 RAMs between the video hardware and probably the CPU. I'm not exactly sure. But it's always selecting, no matter what the select line is doing, it's always selecting this output or this input and sending it to the output. So that is something I'm going to have to check into. Well, guys, I've been doing all the work off camera, as I've really been kind of frustrated by this board set. I really don't care to work on Nintendo stuff, to be honest with you. But it's working perfect now. Video's perfect. No more funkiness up here. No more lines through the sprites. What it turned out to be was ECL. Both of these 125s were bad. And I did go through earlier when I snipped all those legs on all these things. I did go through and I replaced almost every chip on here. There's some that I didn't have. And I think I've replaced every chip on this board. except for the two 123s, and I ran out of LS10s, so I socketed the old one. Other than that, every chip has been replaced on this board. And I mean every chip. And on this board, almost every chip has been replaced. I just went through and kind of renewed this board. Except for these 299s. These, I just probed the outputs on these and they look good, so I didn't mess with them. But all this other stuff that I had a lot of, I ended up replacing it. So I have a super fresh Donkey Kong 4-board stack here. Yeah. Other than, I did not replace that RAM or these 04s over here. As I probed them, they were fine. I don't know, I just got a wild notion to replace everything, and it really didn't take that long, to be honest. Super nice board set there. I do have the soundboard, which I will, I have a friend who has a Donkey Kong. I'm going to put this board set all together and put it through its paces in his cabinet. So yeah, the reason I don't really care for Nintendo stuff is this stupid ECL junk. It's expensive, and I just don't really care for it. That's all. All right. Well, thanks for watching, guys. This was a long one. This was a tough one here. But, yeah. It works. Thanks for watching.